This video will serve as an introduction into polynomials. The prefix poly means many. The prefix mono means one, bi is two, and tri is three. Each term in a polynomial is called a monomial. So therefore, a polynomial is more commonly defined as the sum of monomials. The prefix describes the number of terms in the polynomial. And polynomial terms have degrees that are positive integers, meaning the exponents are positive integers. This little symbol that I'm using is an abbreviation for the word therefore. So I'll let you jot these down, and then I'm going to move on. A polynomial is named based on the number of terms and the highest degree on a single term in the polynomial. A degree 1 polynomial is called linear. A degree 2 is called quadratic. Degree 3 is called cubic. Degree 4 is a quartic, and we won't use this much. Degree 0 rather. The degree 0 is actually the constant. So degree 0 is actually the constant. I'm going to switch colors, and I'm going to talk about what's called the lead coefficient. The lead coefficient is the coefficient on the term with the highest power. We'll call highest degree. The degree of the lead coefficient's term is the degree of the polynomial. And the constant is, I'll switch colors for this, the constant is the term without a variable. Okay, moving on, looking at this little chart, trying to figure out if the following terms represent monomials, and if so, can you give the degree of the monomial and the coefficient of the monomial? I'll do a few with you and let you think about the others on your own. 5x cubed is definitely a monomial, so that's a yes. It's a degree 3, and the coefficient is 5. So it's your basic monomial. So the monomial is a term connected by multiplication. So it's just one single term. And I'll make up a new example. It's an example. It's just one term. You have a coefficient. You can have a few variables. But it's just one term all glued together. Each factor, they're just connected by multiplication. And when you add a few monomials together, you've created an equation or an expression that's called a polynomial. Poly meaning many. I'll let you do the second one on your own. Let's look at this. The degree on the x, this is actually 3 over 2 with x raised to the power of -1. In order to be considered a monomial, all of the powers, all of the degrees have to be positive integers. So this is not. And the reason it's not is because it's 3/2 x raised to the power of -1. So this power of -1 is what keeps this from being considered a monomial. Looking at radical 25n. This is actually, so this is not a monomial. This is actually 25n raised to the power of 1/2. 1/2 is not a positive integer, so that fails the monomial test. And I will let you look at the rest of this chart using that basic information and figure these out. We'll go over this in class. Let me keep going and seeing what I have here. All right, here we go. The quadratic trinomial is where we spend a lot of time in the second semester analyzing and studying this. When you're arranging terms in a polynomial, arrange it so that you have the highest power first, and then just in order from that highest power first. Or if you want to do the opposite, the constant, and then have the powers line up according from largest to smallest or smallest to largest. But highest power down to the smallest power is the most common form of a polynomial. Here I have my quadratic trinomial. Quadratic because it's degree 2, and trinomial because I have 3 distinct terms. The quadratic term is the term ax squared. The linear term is the term bx, and the constant is c. The lead coefficient is the coefficient on the term with the highest power. So this is a degree 2, and we call degree 2 polynomials, we call them quadratics. This is a degree 2 trinomial. All like terms have been combined. The highest power is 2, and there are 3 distinct terms. So it's important that all like terms are combined before you name the polynomial. So the quadratic term would be the term with degree 2, quadratic associated with degree 2. The linear term, the power on the x's to the first. The constant doesn't have a variable with it. If the constant did have a variable with it, it would be raised to the power of 0. So the degree of the constant would be a degree 0. And then the lead coefficient is just simply the coefficient that's attached to the term with the highest power. So my lead coefficient here is a. So just naming the parts. And then here, just naming the polynomial, special name based on the number of terms, naming it by degree, and then in the last column, identify the lead coefficient and the constant. So looking at the first, name based on the number of terms. This is a binomial because I have 2 terms. The degree is 1 because the degree on x is 1. The lead coefficient would be 2. Remember, the lead coefficient is the coefficient on the term with the highest power. And then the constant is 3, the constant being the term without a variable. The second example, this is a trinomial, naming it based on the number of terms. And note that there are no like terms. All like terms have been combined. The degree of the second one is a degree 2. The lead coefficient is 2. And then the constant is 3. I'll do the next one with you, and then I'll let you do the last one by yourself. So here, I'm just going to simply call this a polynomial. Anything beyond 3 terms, let's just name it a polynomial. And here my degree is 3. The lead coefficient is 2, and the constant here is 3. And I think I'm going to let you look at everything else on your own. And there's one other thing just to point out, one other distinction. We will go over these in class, and note only one of these would be, only one is a poly. And I'll let you figure that out on your own, and we'll talk about it in class. Let's see, when you're combining like terms, just to make sure this is clear, when you're combining like terms, you simply add the coefficients. So here you've got some examples, just the ability to recognize like terms, and I'm looking at number 5. And in order to be a like term, you have to have the same variables raised to the same powers. So looking at this, I only see 1 pair of like terms. And since multiplication commutes, AB and BA are exactly the same thing. Let's see, but looking at this a little bit closer, I have another pair of like terms here. I'll highlight those in green. And that would be it, because the power on A in the first term is 5, and the power on A in the last term is 2. So they are not like terms. And I will stop the video here and let you make sure you have all of these things in your notes.